2026. This is a great This is a great presentation today because CSIR lab developed product is now commercialized and available for the Indian customers. It is a truly make in India and supporting nation for the generation of wealth. I already shared his detailed biodata in the attachment of the mail. The membrane is one of the product which is used by many industries for separation. Without spending much time, I will request Dr. Kharul to start his presentation. Over to Dr. Kharul. Thank you.
Thank you, Shri Rabude, your kind introduction and giving me an opportunity to present to this forum. I have been informally associated with many of you, but then it's really a good opportunity for me to tell you something more about membranes, whatever work we are doing at NCL. That's my job as a scientist. And that science to be taken forward for some application. That is what I'm going to put in this my particular presentation. I have two caps, as I already said, scientist as well as founder of one startup. I have divided my presentation into three parts. One, membrane activities at CSIR-National. Second, I'll focus something on my startup. And the third aspect, the membrane applications in Indian context. I thought I'll put some of my thoughts that how the application of membranes can be making certain impact onto societal aspects or in industrial context. So about CSIR-NCL, I think I don't have to introduce you. Many of you may be knowing about National Chemical Laboratory. It's a government-funded organization. We receive funding from different industries or various funding organizations like DST, DBT, whatever. And our activities, I'll broadly focus into four categories. One is R&D related to the funded project. So industry tells us what is to be done. And or whatever we submit to some DST or DBTs, when some funding agencies like this, there are milestones, there are objectives, and we have to reach to those milestones within some defined period. We also do some curiosity-driven research, wherein this is mostly done by PhD programs or certain fellowship, wherein as a scientist, we have certain curiosity in our own areas. And that is what leading us to not only human resource development, but also patents, publications are important. We also take part in programs of national importance. For example, fuel cell, when it started probably 20 years back in NCL, I think no industry was actually focusing on it. But then CSR identified it at a right time, and we started indigenizing each and every component. I think I'll touch upon this at a little later stage. And there are some outreach programs. We go to schools, we go to society, we have some open day programs. So we interact with our stakeholders, especially the public. Coming to membrane activities, in my group at NCL, just move this ribbon. Well, so I'm okay with it now. So we work on ultrafiltration membrane or membranes for gas separation or membranes required for proton exchange membrane fuel cell. And there is one area called chemodialysis, which we have coined the terminology. We make membranes in different form. For example, flat sheet or hollow fiber form. And membrane materials are either polymeric or inorganic. We also do facility creation. I mean, when we want to develop some membranes or develop some test facilities, that we rely on making by ourselves rather than importing anything. And we have some tech transfer from my group. I think I'm going to explain this in next slides. So I'm touching upon some more details about some of the activities. For example, if you talk about drinking water, we know that the ultrafiltration membrane can reject viruses, bacteria, which is a big issue to be addressed in many areas of India wherein surface water is used for drinking water. And we know that we boil water sometimes. So rather than boiling water, probably we can remove viruses, bacteria easily using the membrane. So making membrane is one thing, but ultimately making prototype, its demonstration and performance evaluation is important, because then only we can do tech transfer. Because when somebody is coming to take the technology, I think we need to convince him that the things are working in the right way, they are acceptable by society. And this is what we have done by making several modules like this. At NCL, somebody said, "Oh, we want this modification." So we did all those kinds of modification. And I remember we almost made 100 prototypes like this. And then there was a technology transfer to a company, and they came up with some new propositions. For example, this three-wheeler. So three-wheeler is very popular in India. So that time there almost 70% units were running were actually operated by women. So they were talking about women empowerment, giving water to places wherever it is required, for example, villages, and money generation. Uh, then we transferred this membrane making to another company called Technorbitals Advanced Material Kanpur. And these are the actual units which are available in the market. One of them could be, you may be knowing this Tata Swatch. So Tata's water purifier are based on our technology, because the membranes are made by the Orbital and they are supplying membranes to Tata. These are some demonstrations done by those technology practitioners in villages or whatever. So they also have to reach to the user, and that is what I think they are doing in a nice way. In maybe 7 8 years back, we were using a typical water bottles at NCL. We were purchasing water bottles, but now we have stopped it. Since last 7 8 years, we have this particular unit, which is using just one membrane module, and that's enough for whole NCL to get a drinking water. And we saved a lot of money annually, probably some 24 lakh or whatever was counted at that point of time. And now with some dedicated people, maybe 3 4 people, it's working nicely. Coming to gas separation, I'm talking as a material person now, wherein we need to use different polymers for doing certain separations. And when we do basic research, what does it mean? That find out the basic properties of a polymer, or for a polymer and gas interaction, find out what is permeability, what is selectivity of one gas over the other, employ some new strategies of existing membrane. For example, you may be knowing that the clays are used for making the barrier films. We used it for improving selectivity. There is something called as ionic liquid. I don't know how many of you are from chemistry, but ionic liquids is something like a green solvent. It's called as a green solvent, but we transformed that ionic liquid into polymeric ionic liquid, made some membrane, and probably I have one more slide to show the effects of it. This metal organic framework, it's something like a buckyball kind of thing, wherein you have a typical gate forming ability for those materials, and you can selectively permeate some gases. And I have one example for this to focus in my conclusion. And whatever insight we obtain through some basic research like this is extended to developing the next generation of membrane, which is thin film composite or symmetric membrane, because these are the membranes actually used in actual application. And that leads to publications or patents or whatever. Yeah, I mean, I'm focusing on this because I said I'll talk on this little later. Uh, This polymeric ionic liquid have high CO2 absorption capacity, but unfortunately the reported materials were not able to be transformed into a film form, and that is what we did at NCL, that we did some small change in their backbone. Rather than the aliphatic backbone, we're talking about aromatic backbone, and that led to excellent film formation. And the results were like this. I'm not going to read actually the numbers, but what I'm going to say is that this and this particular two things are commonly used polymers for making membranes for gas separation, versus we have much better properties than this. But these polymers are synthesized in our lab. So they to be taken into actual practice will take a lot of time, and there probably the research and actual implementation, that particular gap still exists. Although we say that our properties are much better in some sense compared to the literature known material, but this is just the research. I think that transformation is still required. I'm talking next on proton exchange membranes for fuel cell. So in fuel cell, hydrogen is used as an energy source. It's oxidized, and you get electricity and heat as a byproduct. Of course, water is again a byproduct, and you get excellent quality water if you could collect it. So in my group, we are working on membranes, which is somewhere here, wherein there's a catalyst and then carbon paper. So fuel cell is a multidisciplinary technology, and what is required is that we should collect expertise from different areas. That is what we did probably 20 years back, wherein NCL came forward. Another CSR lab was Sikri, Karaikudi, and third lab was NPL, Delhi. We came with our own expertise and demonstrated a working fuel cell for long hours, something like around 500. And today you may be knowing that KPIT has demonstrated a bus or a car using fuel cell. So that was something like a combined effort by industry and research organizations like CSIR or NCL or SICRI, whatever. So uh, such efforts probably are required, wherein our R&D to be transformed or to be translated into actual practice. I think we need some bridge, and that bridge probably, yes, people are coming forward nowadays. That is what I'm observing. When we have one type of membrane, the important aspect is that we benchmark that with the commercial materials available. And as you see in this graph, this particular red line is commercial material versus whatever we have. Other graph are showing that they are exactly matching with commercial materials, membranes, or we call it as a membrane electrode assembly. But we cannot stop there. We have to have something better. So this is what the commercial material is, and we have the performance which is almost double than that, and that is what leads to some IP, global IP, some publications, and some PAD. So this is required, because when we work today on this, we must be having something much better available with us. That's why we can remain competitive in terms of global comparison. Now, I have some slides on self-reliance on facility creation. So when we talk about membrane making, yes, we make membrane in flat sheet or hollow fiber form, but the facilities were not available probably 20 years back, or they are not even today available as an off-the-shelf machine. So we have to envisage something. We have to talk to special purpose machine designers, and this I did in Pune, wherein we have world-class facility now with a pilot scale membrane making capability, and this probably give a confidence to to somebody who comes to us saying, "Oh, you have developed something. Now we can take it to next scale of manufacturing." Same I did with the hollow fibers. So this is my second generation or third generation membrane making machine. So we can make membrane with different diameters. They are just put into one into another. They are not spun together, but just to show you the comparison, they are put one inside the another. So we can make membranes with different diameters, and the requirements are the diameter requirements are tuned as per the application. What is important in membrane is that this is scanning electron microscope, and the membrane morphology either inside or outside are going to govern your porosity, and selectivity is an important aspect, and that is what is most important when we make membrane. This is third machine we created at NCL for making continuous membrane making for fuel cell application. So if somebody want the fuel cell technology to be implemented, as I said, that our intention was to indigenize components. That also means that we just not develop components, we also develop how they should be scaled up to some level. I agree that this may not be for the industrial level, but then somebody who comes forward, they will have something to take away in addition to just materials. That is what our thinking is. Now, some efforts led to tech transfer in NCL that was related to all ultrafiltration. I'm a membrane material person, and there were many applications available, many applications possible in India, wherein we can use membrane effectively. And that is where the startup was created in 2014. And we're still the first company in India to manufacture membranes for gas separation. And this startup was originated through lab to market initiative of CSIR. What it means is that I have my technology at my NCL lab, and if I want to take it to a startup, that tech transfer is done in a formal way and with some conditions of CSIR. So CSIR has put some rules on that. So that's how we floated this startup. The intention was very simple. That time when we began and got some grant for beginning this startup, we know the situation of oxygen therapy. We probably know better during COVID time, but then we knew this probably in 2000. I have worked from 1996 to somewhere around 2002 on making membranes for oxygen enrichment, and gave it to different hospitals for treating COPD. This is chronic obstructive pulmonary disease, and asthma patients. Now, there's a large number of COPD and asthma patients in India. If you talk about outside countries, I think they can carry some oxygen cans in their pocket, or they can have some small unit at home. And oxygen therapy has to be administered at home as well to treat COPD in a better way, so that the patient can have better lifestyle and better survival as well. Versus this is what the situation we see in many places in India. What we proposed that time is that when we get oxygen in the cylinder or whatever oxygen units, we are converting existing 20% in the air to somewhere around 99 or 100%, and bringing down to 35% for the breathing purpose for these people. And that we can do with a single stage membrane operation. And that is what accepted, and that's how we floated our startup. And the idea was that we should transform something like this to some Indian village. Somebody should get it easily. That was our intention. And this unit was made. This is one of the unit. I have some other units as well. This is some stage, but then oxygen enrichment unit is having some membranes packed into some box, and compressed air is required. Now this is a physical unit. There is no electricity, nothing. Only the compressor is required, and compressor is a common thing even in villages for puncture applications or whatever. So we thought that this is a good proposition for Indian society to get percolated. And we have all these properties. I think I'll not go through this, but this is a portable unit. It doesn't require high energy. We think it's efficient. Not only we, the pulmonologists also think that this is a efficient unit. And we made different units like this. This is first version, second version. This was the third version in 2022. As you can see, the cost 1.2 lakh versus 90,000 versus 35,000. We also made something for villages wherein there is no electricity, or for remote places wherein you can put it on a bike, and with a separate compressor which we can provide, it can be operated. Now, there are other applications. For example, high altitude. I think I'll touch upon that on little later. But when we take different units like battery oxide, they provided COVID. With COVID, we can apply units like this. Now, as a starter, we have a lot of awards.
No sound.
There's no voice.
Are you getting me now?
खारुल सर आवाज येत नाही आपला.
Hello, am I audible?
Now you are audible. For last 4-5 slide, you are not audible. Can you just go back for 5 slides?
Oh my God.
Yeah, from
Am I
this
audible
point
now?
onward. Yes.
Yeah, am I audible? Yeah. I'm sorry, I don't know what happened, but then I hope everything is okay now. Am I audible?
Yes, sir. Please continue.
Yeah, thank you very much. Thank you very much. So I said that oxygen enrichment unit is nothing but that the membrane modules of this kind are packed into this box. And this is a physical unit. There is no electricity required. There is no extra energy required for this. And only the compressor is required. Your 5 amp plug is enough. And we made different units with different properties or upgradation, I would say, that initially when we started in 2015, the cost was this, then the cost was reduced to 90K, then the cost was reduced to 35,000 in 2022 when there was a COVID. This is, I think, the scale-up aspect as well as developing further. So cost can further go down if more efforts could be put onto this. And these units were made for carrying along with the person, which is operated on battery. So we were successful traveling to this stage. And then COVID came, and during COVID, we had demonstrated some units like this in different hospitals. Almost 65 units we made. Well, our startup has some laurels. We got some attention of the people, and that is what I think the importance of this particular slide. During COVID, we worked with Bharat Electronics. They made some unit like this. We gave it to different hospitals. They gave us their feedback. And I think now there is no real development on this, but I still feel oxygen therapy for COPD for using at home is still an addressed need, and that can be addressed using this technology. Now, oxygen can also be used in some other industries like fermentation of biotech industry. I think I'll talk a little later on this. In fertilizer or cement industry or control oxidation in pharma sector. And we have done some efforts, supplied some units with something like around 200 LPM capacity or whatever. Another application which we are addressing at my startup is dry air. Now, dry air applications, when we started, I thought it's limited to certain areas. But then as we talk to people, we understand that there are various sectors listed here which probably use dry air. And for them, today, the technology of dry air versus the membrane technology, I think that I'll talk in my next slide. What are the advantages or whatever. Another application we did in my startup is something like hydrogen recovery from a refinery. Now, if you have seen the chimney having some flame, there are 3 types of flame. One is almost colorless or blue color, I would say. Another is red, and another is with smoke. So wherever you have all these kinds of flames coming off, there is a hydrogen also sent. And when you talk about blue flame, that is mostly hydrogen. And that hydrogen is not getting recovered because it's not probably commercially viable as per their proposition, which is being carried away since so many years when they established their particular setup for hydroprocessing. I feel today the technologies are developed and engineering is developed, and with this, what these people are telling me that their ROI is hardly 6 months or 8 months if they put these particular membrane units to recover hydrogen and reuse it. So such possibilities also exist. Another is biogas. So I'm just showing as a comparison that this is a typical PSA, pressure swing adsorption based unit required for purifying 30 meter cube per hour gas. And this is the membrane unit which was put to this compressor, and they are using it for refilling their cylinders and selling it. So the required, the as per the Indian norms, the purity requirement is 95 to 96% that we could achieve. Recovery of methane was achieved to something like around 90 to 97%, and that is a big achievement, I would say, in terms of recovery. And there the PSA unit does not give this much high recovery. This is what I understand out of whoever are using this PSA technology. And most importantly, the lower footprint. The footprint is lower. Probably the energy requirement in terms of compressor usage should be lower. This is what I think my understanding, but then that has to be further evaluated in Indian situation. In outside world, if I talk about biogas, yes, all of them are using membrane technology. Another area we developed is something called as tubular membrane. Imagine you have some water with lot of solid content that can be used, that water can be recovered using a tubular membrane, wherein these membranes can be easily used with high solid content of around 20,000 to 30,000 mLSS. And this was, I mean, we just made the membrane, and this was used, this was actually a project funded by Thermax, and they were working on membrane bioreactor, anaerobic MBR, wherein they wanted to treat sludge using these membranes. They were successful. We have done some efforts during COVID time. I thought I should tell you that as well. So everybody was worried about virus being there in the air. I'm talking about 2021. So we filtered the air through a membrane, and we call it as a virus-free air. We know that we can make membranes which can reject viruses, bacteria, and particulate matter. Virus log reduction was this, and this we just when we say virus is rejected, that also means that bacteria and particulate matter is also rejected by that particular membrane. So that was used for betterment of the COVID warriors that time. For some unit like this was made, and I hope Mr. Rabde would remember that I was asking to this forum that can I get some small compressor, and what we used here is something like some small compressor which is used in fisheries for incorporating air into the water, and that was enough. This is of course some box used for electrical whatever panels or whatever, and we could demonstrate some units like this. Many hospitals liked it. Then they suggested that, oh, we want for a room as well, or there should be parallelly 3-4 possible users should be using it. So we have provided along with the compressor. Somebody said, oh, I want to use it while I'm sitting at my home or in my office. So that kind of efforts were done. Well, now I'm coming to my third section, wherein my personal thoughts on Indian context on using certain technology like membrane. So India, we have a vast diversity in different aspects. For example, biodiversity or food, that means food processing or agriculture industry, temperature variations, economics, the societal aspects. I think we have our own problems, and the solutions are to be found by ourselves. What it means, what I want to say here is that, well, something is demonstrated in developed countries and that we can replicate, that may or may not work in India many times. That is what I think I learned out of my interactions with either society or industries with whom I worked. And thus I'm making this statement. It may be controversial, but yes, I think we have our own problems, and we will have to probably find out the solutions by ourselves. And I can, I'm saying this based on my short, very tiny understanding about societal aspect or industrial requirements limited to my small membrane area. So, membranes are demonstrated in water purification, in food processing. For example, if you take any fruit juice, appy, whatever, that is certainly, apple juice. So those kind of things are certainly gone through the membrane for clarification purpose. In environment, you can talk about CO2 removal, you can talk about air purification, energy. I discussed that you can use fuel cell. And there are many other sectors like chemicals, pharma, textile, aviation industry, leather. You name industries, probably membrane can be used there, or are being used there in a conventional manner. In all these areas, if we divert little bit, I think we can do much better than what is imported technology, I would say here. So membranes are conventionally used for water purification as RO, UF, MF. Now there are opportunities. There is something called as nano filtration. Now, hardness removal, we are not talking about sodium chloride removal. So RO is to be used when sodium chloride is to be removed. So monovalent ion is to be removed from water. But when you talk about hardness, it's calcium or magnesium. And if you use nanofiltration membrane, probably the pressure requirements are low, your energy requirement is less, and your recovery is also higher. So those aspects should be incorporated, I feel, in our Indian situations. If you talk about organic solvent nanofiltration, it has a big importance in industry, and NCL is working on these kinds of membrane. There is something called as membrane distillation. Now, when you compare RO reject, at certain point of time, you have to throw the large quantity of reject. And you can recover water by using membrane distillation, which is a cost-effective solution, I feel, and it is also said in literature. It's not that only, I'm talking about my understanding, but yes, it's demonstrated in the literature. But as I see, I don't see many of these things in India. Now we talk about if I talk about some industrial aspects, for example, zero liquid discharge, they just take the water and put into multiple effective evaporators. I think if this technology could be combined with multiple effective evaporators, I think you can get water recovery, you require less energy, and those aspects probably we'll have to address by ourselves. I don't think, because in India the industrial sectors are so diversified that they will have to find their solution by talking to different experts like this. I'm just talking about membrane distillation, but there could be many other things for an industry wherein they can do something better than what they were doing earlier, maybe 5 years back or 10 years back. Another application of membrane bioreactors, sewage and municipal water treatment, huge opportunity in India, wherein we can treat the water. And in industry, you know that the water has some cost associated with it. Again, ultrafiltration for poultry industry. Now, as I was talking to some of the poultry people, and they said they have to deal with these viruses and bacteria, and they are using chemicals or whatever. Versus if you use ultrafiltration, that clean water which is free of viruses, bacteria can be given to the animals. In food processing, water reuse, I think ultrafiltration has a lot of potentials, and the list can be can be extended further. When we talk about dry air, the conventional technologies are freeze drying or cryogenic technology, wherein the energy requirement is high because you are lowering down the temperature for large quantity of air, whatever you are using. and then again taking it back to the ambient conditions. So that wastage of energy, you are cooling something and taking it to ambient temperature. So I feel it's a wastage of energy. Versus if you allow water to be permeated through the membrane, I think you don't have to change temperature. Water can easily permeate water molecules in comparison to the air components, oxygen, nitrogen, argon, whatever. So such membranes exist and we have demonstrated it. Another technology is adsorption, and silica, alumina, they are, they are bound with their life. So you will have to take care of their regeneration or whatever. And in my membrane, in membrane aspect, probably these things are not to be taken care of. I already said that it is low energy aspect in terms of energy requirement. You just need a compressed air, nothing more, and it has a long life. I mean, around 5 to 8 years easily, and that is what I'm observing in my lab. Since last 7 8 years, we have installed one membrane dryer there, and it's still working. So coming to application sector, storage of either food or chemical or whatever, which is hygroscopic, packaging applications, transportation of agro products, and storage of this cotton. I mean, I discussed with some people who store cotton or grains, and they say, oh, we have this technology that they have large surface area, they spread it over there. Because when cotton or grains are obtained from a farmer and they are stored by a middle person, before it goes to actual market, I think a lot of wastage is there, and that wastage is because of the remainder of moisture when the stuff is collected from farmer. So that moisture can be taken care easily by using this dryer, I feel. And there's a lot of potential here. What is required that we have to come forward for some small investment or for demonstration, and then probably once it is demonstrated, people will catch up easily. So this is one aspect which I thought I should cover today. Processing of agro products, for example, grapes. We are still using conventional technologies which are available since last 25 years for drying the grapes. I mean, when I discuss with someone, they are saying that they are using sulfur powder for removal of bacteria and viruses. I think dry air can certainly do that. You have to have some air which is entering at certain temperature, and the same is applicable for other maybe sometimes we feel that, oh, tomatoes or maybe onions are becoming very costly, versus when they are I mean they are becoming either very costly or very low cost, that sometimes farmers throw it. I think those situations can be avoided if we put one step forward for using some better technologies like membrane. I maybe there could be something else. For example, if I take the solar energy available to me, I think that's a very good amalgamation. Somebody has to do, and that certainly cannot be scientists alone. Humidity related issues in Indian environment, for example, pharma, electronic industry, we're talking about summer season, we're talking about winter season, versus we're talking about the product quality. I think all that can be catered if we widen our scope to some small extent to make our products better. Another aspect I'll talk about, this drying of biogas. So I understand from someone that, oh, they don't want biogas in 96% purity. They just want to remove water from that. Because biogas, when it is produced from the fermentation, it has almost 100% humidity. And they said, we don't know how to use it. And we use membrane at very small pressure of around 0.5 bar, and we could remove humidity. Their requirement was around 60%. We could easily do it in 25% humidity from 100% in single stage operation. I think such new things probably are required. In gas separation, I already said that oxygen enrichment has some other applications. I'm putting some other applications here, for example, spa or home therapy. We see this oxygen spa in various airports. I don't know whether they really have increased oxygen percentage, increased oxygen percent in the air. I never had been there, But then there could be some applications like this, hyperbaric chamber. I think they are using oxygen cylinder, which is completely unnecessary. Similarly, nitrogen enriched air, there are various industries wherein they require inert atmosphere. And we can certainly use this nitrogen enriched air available from the membrane. Other applications of gas, I already talked about drying of biogas, propylene propane separation. We have some materials. I showed you this figure some slides in some earlier slide. And if we use, you know the importance of propylene or polypropylene. So when propylene is manufactured, propane is also present there, and propylene propane is that particular propylene propane separation is done today by using distillation columns, and the height of those columns is somewhere around 75 to 100 meters. Versus if you use membranes, that can be done at ambient temperature using some membrane which intelligently will permeate one of the component. And we have global IP on this, but then there has to be someone who should help us in taking this forward to the next stage. I discussed about hydrogen recovery, and there can be many applications on gas separation like this. Uh,
No sound.
I'm sorry. Am I audible now?
Yeah. Okay. Go.
Yeah. So when we talk about Delhi air in winter season, I'm touching upon that particular aspect through this particular slide, wherein if we get a small blower with 5 psi pressure, I think we can easily remove viruses, bacteria, and all particulate matter. Whatever air purifiers are available in the market today, they are based on some PM mark, so that particulate matter of that particular size, but then that doesn't take care of viruses or bacteria. So we can also talk about CO2 separation when the cities are polluted. So there could be several propositions which can emerge out of meeting together or discussing, and thus I was very happy when Mr. Rabde said that, oh, I should talk here. I said yes, I'll put my thoughts. VOC removal, this volatile organic compound smell in industrial areas, I think is very important aspect, and that can be easily catered by using membrane. And that VOC removal can be from either air or water. And I'm talking to one of the person from your group, wherein he exposed me to some electronics area, or one typical area wherein there are issues which can be probably easily catered if we go for some new thoughts or for some newer application. What is required is some small money to be invested, and if you invest money maybe in 10 things, maybe at least one will succeed. That is what my proposition is as a typical Indian status of thinking. So specific opportunities, for example, solvent dehydration. We know ethanol. Ethanol, if you want to add into petrol, it cannot have water. And ethanol, when it is distilled, it has 5% water there. That is called as azeotropic mixture. And whatever solvents used in pharma, they normally form azeotropes. What membrane can come to help very easily. And I don't see any of the unit in India, although this is known in or practiced in outside world. I remember in 1983, there was the first plant installed in Europe for ethanol dehydration, which still don't have in India. This alternative to distillation, I'm talking about for product recovery. So you can use membranes for selective removal of solvent, and you can save the cost of distillation, where you're talking about a huge cost. Distillation is a high cost operation. I remember in many of the European countries, Indian aroma is always preferred. Now, when that Indian aroma, the way it is purified or prepared or collected, I think there are so many opportunities here in this particular area. I talked about recovery of hydrogen from flue gases. This is today accepted by one refinery in India. I would go to other people as well who are doing hydro processing, that oh, you can recover hydrogen and use it, because hydrogen costs a lot now, especially when we are hearing from PM or various ministers regarding hydrogen economy as a buzzword. But yes, that hydrogen we need to recover or reuse or produce by using water splitting, and membranes are used in water splitting as well. This is what I thought I should tell you. But then when I talk to those people, none of the membranes are commercially available in India, and they say the cost of imported membrane is high. Now, membrane as an area has this tag associated with it, that the costs are high and the performance is not consistent. If I operate a RO membrane in Delhi versus I operate a RO membrane in Pune, the situations are different. And that needs, I mean, I don't mean that the membranes are bad. I think there are some operational parameters or some engineering involved with it or some chemistry involved with it that has to be understood, and then probably we can get the better results. We should not cut short on certain things. So supercapacitors and batteries, I think many of many of your forum people are aware about the supercapacitors and batteries, and they are using separators. Those separators are nothing but the membranes doing certain functions. Now, in chemical industry, esterification is an age-old technology wherein membrane reactors can be used. So that's another aspect which could be developed in India. Chemodialysis, I said that this is the terminology we coined and accepted by reputed journals, for example, Journal of Membrane Science. I'm saying it has a capability to revolutionize acid recovery or removal or mitigation in a techno-economic manner. We started this area for recovery of lactic acid from fermentation broth. And as I compare with the literature, conventionally 7 to 11 steps are required to recover lactic acid from fermentation broth. If you use this particular technique, the steps, the numbers are reduced from 3 to 4. And that's a big change. But what is required is that science has to be translated for actual usage, wherein they are talking about 7 to 11 steps. So another example is something like a pickling industry, or many chemical industries. They talk about their effluent containing acids and bases. I think this particular technology can be used over there. I mean that research we have done, we have to take it forward. So probably I'm coming to my conclusion. So membrane by itself forms just 30% share of any separation application. What it means that we also need the help from other engineering aspects, for example, mechanical or electrical or control systems, or users, some interfaces, or some post installation hand holding. I think this is missing in India, and that's why somebody says, "Oh, RO membrane in Delhi versus in Pune versus in Chennai are performing." I think something is missing there. Need for hybrid technologies, for example, PSA. I discussed about this, that membrane plus PSA that can give better solution rather than using a single technology in some of the cases. I also talked about solar. If we use this solar in coordination with membrane, I think we can do marvels in agriculture area, especially in agriculture, I would say. This is what I have speak today. And what I say that whatever R&D activities we're doing, they are curiosity driven. Certainly they are demand driven, because I have been working with some industries, and we are focusing on addressing real life applications through these two things. And that is where I have some industry collaboration right from foreign industries, Indian industries, some institutions. And with this, I conclude. Thank you very much for your attention.
Thank you, Dr. Karul, for this wonderful presentation. Membrane, so many applications,
Yes.
and really a very good import substitute product. We will put this floor for question and answer. I request all the participants to identify yourself, tell your name, and then ask the questions. So over to the audience.
Hello.
Good morning.
Hello, good morning.
Good morning. I'm Pramod Deshpande. Long back we met in 2000. That time I was doing some work with IIT. I don't know whether you recollect. It's okay. We are having the fuel cell for basically decentralized power generation will come in a big way, where people will use hydrogen, and there should be a capacity development for fuel cell manufacturing, maybe from say 5 kilowatt or 25 kilowatt or 100 kilowatt. So is NCL is in a position to
Oh,
give the guideline that what way the things can be designed so that we can get fuel cell can be, means there are people who are interested in mechanical engineering who has a capacity to do fine what is called as fine machining and things like that, and they are ready to do the component, but whether the whole system will be workable, whether the how to do the testing, whether the PMA membrane is effective, so what way the NCL can able to help in that matter.
सर तुमचा ऑडिओ येत नाहीये.
No sound, Dr. Karul, no sound. Still no audio.
Sorry, I think my earphone was not working properly. Am I audible now?
Yes.
Yes, yes.
Yes, go ahead.
I think I removed my earphones. So some technology is not helping me. Fine. So when we started fuel cell activities in NCL, probably 20 years back, we started with one component saying hydrogen generation. But later on, we realized that we'll have to indigenize all the components, either catalyst or whatever. And it's a multidisciplinary technology. We certainly welcome participation from different industries, and we have been working on that. For example, I said about KPIT, we have Reliance with us, but we have also small scale industries who are helping us in different aspects. For example, making carbon bipolar plate or carbon paper, or mechanical engineering. You rightly said that it's a big input required for designing a big stack, provided the materials are available. So certainly industries are welcome to participate. And what is required is that probably you can write to Director NCL that yes, you have this capability and we have this interest.
Okay, thank you.
Yeah,
Hello.
next question.
Hello. Am I audible?
Yes,
Yeah,
Tushar
you
Patil.
are.
Yes, sir. Professor, good morning. Myself, Tushar Patil. I am working as a senior research fellow in PDPU Gandhinagar University. I am working on a gas suppression membranes, which is basically inogel membranes. And normally we face some questions like percentage separations of CO2. It will be very difficult to answer that questions because our permeability and selectivity results in barrier only. So normally, if we look for the percentage separation of gases, it will be difficult. So how to look at that point? Can you suggest some ideas?
Well, CO2 can be detected from very small level to large percentage. So analytical facilities are available. I think you're talking about membrane area to be enhanced, if I'm not wrong. So if you have
Yes,
a
yes.
material ready, whatever membrane module we are making at my place, in one module of 1 meter length and around 4-inch diameter, we are incorporating 40 meter square area. Okay.
Okay.
So membrane scale up is another aspect which needs to be coupled with your scientific developments or your scientific achievements.
Yes.
Yes, ionomers are very important materials for CO2 removal, and if you could succeed on that for high CO2 selectivity over other gases, certainly wonderful. Membrane area needs to be enhanced either in hollow fiber form or flat sheet form, but usually gas separation is done with hollow fibers.
Yes, sir. But I have currently 3 patents on the compositions,
Very good.
and I have get good permeability and selectivity results. But normally, when some other person asks, no, like percentage separations, because my membranes are flat sheet membranes, and area is very small. So I'm facing some difficulties for answering that kind of questions, percentage separation.
So, Mr.
So,
Tushar, we can discuss offline.
yes.
We can certainly help
Sure,
you
sir.
either at NCL or either at Genrich. I hope you have noted down my email
Sure, sir.
address.
Yes, sir. I will mail you by the end of the day. I will mail you, sir.
Sure. Yeah.
Thank you, sir.
Okay.
A very
No, I think
wonderful
Mr.
presentation, sir.
Yeah, Mr. Vishwas Kale have some question.
Sorry,
Over to
I'm
Mr.
unable to
Vishwas
see the.
Kale.
Yeah, please.
Mr. Vishwas Kale, you have any question? No. So let's go further. Is not audible or what? No. His mic is on. Okay. Any further question? I think we are reaching 11 o'clock. So, friends, thank you very much for attending the program today. Yeah, who is calling?
Hello.
Yeah, go ahead.
Hello, I'm
Sudhir Samre.
Sudhir. Yeah,
Yeah,
I have
go
one
ahead.
question. So, I'm Sudhir Samre from Aurangabad. I have one question. Can these membranes be not applied for filtering the exhaust gases of automobiles?
Not really. I mean, from automobiles, for a particular, for an individual vehicle, applying membrane is difficult. But if you say yes, membranes can be applied for power generation plants wherein large amount of CO2 to be separated, I think those efforts are on. But as far as vehicle is concerned, it's a bit difficult. It's not, well, technology is possible, technologically it's possible, but it may not be a techno-economical solution.
Okay. Thank you.
Okay, friends, next question. Okay, I think we are approaching 11 o'clock in the morning. So I must thank Dr. Ulhas Kharul for this wonderful presentation and applications. Those who are interested, we can always visit his lab and see the activities that he is doing. It's quite interesting because I visited him